Um, does anybody have any questions from the doodads? No? Okay. And reminder that we had, last time I had put up the chapter 1 test format. That's happening when? Thursday. Sounds pretty similar to the quiz with a couple of extra topics, right? So again, I handed back the quizzes. We talked about the quizzes. If there was something there that you kind of like mucked up a little bit, try to get that stuff tightened up for the test because it'll be pretty similar in format, right? Okay. Today then, if there's no chapter 1 questions, we're going to start talking about chapter 7. Remember, the order we're going is kind of kooky because I want to get through all the content we need to do the IA in first semester, so it can be a first semester activity. We can do it as our final exam grade, and then we can not have to worry about it second semester or a end of semester exam, in class exam, right? All right. So the PowerPoints that we're looking at, again, I've posted all of these to My Notre Dame if you want a copy. All the Chapter 7 PowerPoints are on My Notre Dame. Again, I don't know that you necessarily need to write any notes for this because you have the PowerPoints. But if you want to sit and listen and maybe participate a little bit, that would be pretty cool. Everybody ready to rock and or roll? Okay, some of us are just rockers, others are just rollers. Got to do one or the other, though. There's no idling. Yep. We don't end up mossy stone here. All right. So today we're going to be start talking about descriptive statistics. Really, all of first semester is going to be kind of geared around statistics. So when we talk about data analysis, we say statistics is the science of data. Yay! And data analysis is the process of organizing, displaying, summarizing, and asking questions about data. So when we talk about data analysis, there's kind of two big things here we want to talk about. The population that we're sampling from, so that's the objects or individuals described by a set of data, and a variable, that's the characteristic of a population or individual within a population. So, for example, if we take the population to be students in this class, and the variable to be height, that could be something we could measure, right? We'd record each student name and their height. Everybody's okay with that? Alternatively, maybe the population could be cars in the parking lot. And the variable we could measure there is color or something. So we could record, each car and each color and how many cars we have of that color, right? Notice that those two variables, height and then color, are kind of different, would be measured differently, right? Height is what you'd call a quantitative variable because we're going to describe height by a number. Color is a qualitative variable because we're going to describe color by a word, right? So the statistics you might use for quantitative data and qualitative data would be different. Much more you can do with quantitative data than qualitative data from a statistics standpoint, right? All right. And just as a clarification, you can't take something like color and try to make that quantitative data by just assigning like, okay, red is going to be 1, blue is going to be 2, green is going to be 3. Like just kind of numberifying a color doesn't make it quantitative anymore because there's still no measurement really happening. Is that, everybody's okay with that? Okay. All right. Oh, here we go. So again, qualitative data separates the population to one of several groups or categories, usually with a word, like you could separate the students in class by biological sex, by, male and female. Or we can measure by height. That's a quantitative measurement, Okay. So there are 2 types of quantitative data. So one of them is discrete data, which can take only certain distinct values like whole numbers or specific categories. So like color is a discrete type of data, right? Because there's red or there's blue, but there's not like, red point blue, right? You can't have that. If you're looking at the number of students in class, that's also going to be discrete data because you have to have a whole number of students in class. You can't have, this class has 3.2 students in it. Well, that's not a thing. What the heck is a 0.2 of a student? But if we're talking about height of an individual, that's continuous data because you can measure a height of some person down to any decimal point you want, right? You could be 5 feet 10 inches. You could be 5 feet 10 inches and a quarter. You could be 5 feet 10 inches and 2.6432789. Like as accurate of a measurement as you can take with your tool, but you can measure that much. Is everybody okay with that? Difference between continuous and discrete data? Okay. If we're measuring the number of A's on a report card, is that discrete or continuous? Number of A's on your report card, discrete or continuous? Discrete, right? Because can you have half an A? Nope. What if we look at your class average by percentage on your report card? Is that discrete or continuous? Continuous, right? Because you can have 83.27 or something as a grade. Everybody's okay with this idea? So for chapter 7, a lot of what we're going to be asking you to do is like identify stuff. So like the vocab's important. There's not a lot of calculation going on or difficult calculation. Really in all of the first semester, the calculation is not terrible. But there's a lot of like vocabulary and understanding like, what kind of situation am I in? What can I do in that situation? Okay. And some note here, qualitative data is always discrete. Right? If something is either a category or another category, there's no such thing as like in between 2 categories, unless you make a third category to house those, right? Like if you did colors of cars in your parking lot, it's like, okay, we have blue, we have green, and then let's make another category for blue-green, Like we've all seen that weird color that cars sometimes have that's like in between blue and green. But you can't like, again, it's still a whole discrete category to hold that color. You can't call it like, this is midway between blue and green. Okay. So a variable generally takes on many different values, and we'll be interested in how often a variable takes on each value. This is called a distribution, and that tells us what value a variable takes and how often it takes those values. So in the table below, what we have are some car makes and models, and then their miles per gallon. What is the variable in this? The miles per gallon, right? And what is the population? Cars, yeah. There makes and models for cars. So one way we could represent this data set is with something called a dot plot. So notice I put the miles per gallons at the bottom, and every time I had something like the Bentley Arrange, I don't know if I pronounced that, is 14 miles per gallon, so I put a dot at 14. But nothing else has 14 miles per gallon, so that's it. Notice at the Cadillac CTS is 25 miles per gallon, so I put a dot there. So is the Jaguar XF, so I put another dot there. And so is the, I see 3 dots on, where did I miss the other 25? Maybe the graph is just wrong. That's embarrassing. Anyways, you get the idea, right, for the dot plot? Okay. So let's look at some other ways we can explore this data other than perhaps just graphically. So again, this is the data set. So these, again, car makes and models along with their miles per gallon. So what we're going to do is we're going to first look at examining each variable by itself and then study the relationship among the variables. So again, the variables in this case are the car model and then the miles per gallon. So oftentimes we're going to start with a graph to represent that, and we'll talk about the different graphs that we might use to represent our data sets or to describe a distribution. And then we might add some numerical summaries. So, for example, what we did here on the calculator was calculate like some statistics based on the miles per gallon. How come I didn't try to do a 2-variable statistic and include also the car models when I did this on the calculator? Yeah, the car model is a qualitative variable. I can't do really anything with that in a calculator, right? So I am restricted to just concerning myself with the mile per gallon quantity since it was purely numeric. Is that okay? So far, so good. And again, we're kind of always going to start with visualizing our data. So what's the point of trying to do this? Well, you want to be able to make some generalization about that variable inside of a population, right? You know, like if you look at all the miles per gallon of all the car makes and models, you can make an argument that cars are getting more or less fuel efficient over time, right? Or if you looked at all the miles per gallons for, you know, a certain brand of vehicle, you can say, okay, well, this brand is more, you know, like fuel efficient conscious than another one. You can make arguments like that. So the idea here is you're going to start with some population. But for the most part, sampling the entire population is not feasible, right? If I wanted to go and test every single car on the road and look at that individual car's specific miles per gallon, that's not really plausible, right? We're not going to be able to do that. There's too many cars. That's too time consuming. It would be tremendously expensive to do this. No one's going to do that. Instead, what they're going to do is they'll take some subset of the population. We call that a sample. And we'll look at that sample's miles per gallon and kind of extrapolate that so we can say something about the entire population. So how we take that sample is going to be very important. So the key word here is we want to be collecting a representative sample. So what does representative mean?
It represents the whole population.
Okay. In what way?
Varied diversity.
Okay. So you want the same kind of diversity of sample, or in your sample, that you see in the whole population. So for example, if we're interested in looking at hair color as a variable, and the population that we're sampling in, 10% of people have red hair, ideally we want our sample to have, or 10% of our sample to have red hair, right? To kind of match what's going on in the overall population. Everybody's okay with that notion? Okay. Once we've collected our data, as our sample data, we're going to do some kind of data analysis on that and then make an inference about the population. So this is kind of, in statistics, the typical cycle of work, right? You decide on a population you're interested in studying. You collect a sample from that population. You do some kind of data analysis on your sample. You use the results of that analysis to make an inference about the population that might drive, like a policy decision, either from a corporate level or a governmental level, or like in some kind of administrative level, but you're going to use that to make some kind of decision about what to do or how to treat or make a rule inside of that population or how to study that population or whatever. So these first two steps in our process, collecting and analyzing data, these are mathematical in nature, right? And as a result, they kind of provide us with a specific answer, right? You collect some data, you have a sample, that's the sample. You do some analysis, you get a number, that's the number. That part is all cut and dry. The part that's open for interpretation is the inference piece, right? Is how you're using those numbers to make a decision or make a judgment or make a observation or something, right? Now you can do a good job on that and be okay. The judgment you've made, the prediction you've made makes good, rational sense. Or you can kind of fudge it a little bit, right? And maybe twist your logic so it fits the outcome you're looking for. And note that two people can make two different inferences and both be valid. Could both be logically valid on, where one is using one numeric result and another might be using a different numeric result. Or they might view that numeric result in two different ways, right? Okay. So let's start talking about this sampling process. So the population in a statistical study is the entire group of information or individuals we want information about. A census collects data from every individual in the population, right? Every 10 years, the United States does a census and tries to gather some data about every single American or every single person living in the country. I think whether their status is legal or illegal, I believe, is the goal of the census. A sample is a subset of individuals in the population from which we collect data. So this distinction between like population and sample is like a fundamental part of statistics. To make sense of any result, any analysis you might gain from a sample, you have to know about the population the sample is representing, right? Without knowing where this sample came from, it's kind of meaningless. We can't make any inferences about a wider population if you don't know what population you sampled from, right? Like if I had a statistic that said, you know, the average 14-year-old spends 6 hours a day on homework, and you're like, well, that doesn't seem right. I don't think I spent 6 hours a day when I was 14 on homework. And it could be because the population we sampled from was, like a highly competitive, like magnet school population, right? It's like, oh, well, you meant the average 14-year-old in this magnet school, right? So you get what I'm saying. So ideally, again, the best sample you could have is a census, right? That's going to give you the most accurate analysis of what the population is actually like. The problem is it's really expensive, either from a cost standpoint or a labor standpoint or a time standpoint. Like an actual census of sampling everybody isn't really ever done outside of like the US Census, right? Like it has to be something at that kind of level to where everybody is getting sampled. And even there, do you think everybody returns their census stuff? No, right? Like the census workers will go hassle you, but there's lots of people that live in the United States that'll slip through the cracks because they have no address or no permanent address, or like they are existing in a like not on paper. Maybe they're like some homesteader that just like has a cabin in the middle of the woods and they're off the grid, right? There's lots of people that'll slip through the cracks there. Okay. We say a parameter is a numerical characteristic to the population, and a statistic is a numerical characteristic of the sample. So what we want to say here, the parameter is like the actual thing that's going on in the population, right? The statistic is what's going on in the sample. Ideally, we've selected the sample so that it's representative. So anything we can say about the sample should also be true about the population. But depending on how we do that sampling, that may or may not be, more likely to be true. So P parameter, population. S statistic, sample, right? The P and the S help you keep those two straight. Okay. So inferential statistics, these are, what we're doing here is we're trying to find statistics that we can make an inference from that'll say something about the population. So again, we start by selecting a sample and then collecting data from that representative sample. And eventually, we're going to use that to make an inference about the population. So again, we're just looking at the same picture. What's the benefit of using a sample over a census?
Easier.
Yeah, it's way easier to collect, right? And even getting a representative sample that's large enough can still be really difficult. A census is oftentimes like just infeasible from a reality standpoint. What are the potential drawbacks to doing a sample, though?
You don't get a good representation.
Yeah, it's possible that you may not end up with a representative sample. And if you're not even sure what your population looks like, it may be really difficult to get a representative sample. Again, like if you're talking about, political leanings of America, really difficult to even know what the political leanings in all of America are to get a sample that's representative of that, right? That's not something that's easy to look at and figure out. You actually have to ask the person and then expect a true result to come back from them, right? Like, it's not something as simple as like income where you have tax data or something potentially that like, okay, you can't really lie about this, even though the rich find good ways of kind of lying about their income to avoid paying their taxes. Anyways, when I say rich, I mean like the mega rich, the billionaires out there that are like, oh, I had zero income this year because all of it came in through these other streams. So all I did was collect or I didn't pay any taxes because all I got was stock. All my income was in stock shares or something. It doesn't count as whatever. This is now irrelevant. I'm going to stop. Okay. So again, we're building out a sample. We want to try to build out this representative sample. One way to collect data from a sample is through a survey, right? So how are we going to go about choosing our sample? So again, first thing we want to do is define the population we want to describe. So maybe it's American teenagers. Maybe it's, or cars on the road. Maybe it's, hummingbirds. Maybe it's desk chairs. Who knows, right? Any of these things could be a population that we might want to describe. Step 2 is going to say, we want to state exactly what it is we want to measure. So we want to have a good, clear idea of what it is that we want to measure so that when we craft our survey to select our sample, we can get the data that we really want from the individuals. So a sample survey is a study that uses an organized plan to choose a sample that represents some specific population. Step 3 would be then deciding how to actually choose a sample from that population. Again, step 2 is really important because it's going to help us decide whether our sampling was good or bad, whether we had representative or not representative data. All right, ways that we can do sampling. A sample is chosen by chance rules out of both favoritism by the sampler and self-selection by the respondents. A sample can be chosen, I should say. One type of sampling is called random sampling, and this involves using a chance process to determine which members of a population are included in the sample. What are the pros of random sampling? It would eliminate selection bias, right? As the sampler, you might be more willing to just choose people you knew, right? Or, like people in your town or whatever. What is the con of random sampling?
Since it's random, you might not get the population.
Yes, so there is still a probability that your random sampling could be wildly non-representative, right? Now, the bigger your random sample is, the less likely that is to occur, but it's still a non-zero probability that your random sampling is like, oh, look at this, my random sampling, I got, 75% of the individuals were redheaded. Could happen. So there are different types of random sampling. The first type is called simple random sampling. So a simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance of being selected as the sample. So again, that's just saying everybody in the population is equally likely to be chosen for the sample. There's no weight built in. In practice, you might use a random number generator to do that, to choose the sampling. If you don't have a computer, how else could you do this? It's like draw names out of a hat, right? Use some other like randomized process. Roll dice, table of random digits, all of those kind of things. So how would we do this in practice, assuming you have access to a computer? Everyone in the population gets assigned a distinct label, so some numerical number, ideally 1 through n, where n is the size of your population. So like Diego might be 1, Isaac 2, Gavin 3, etc. And then we might randomly choose some numbers and say if we got we pick 7 and 10 randomly. So 1, 2, 3, 4, 5, 6. Maybe Lucas is 7, 8, 9, 10. Maybe Alexis is 10. So it might be Lucas and Alexis would be the people randomly selected. Let me go back for 1 second. Here, let's actually do a random sample on the calculator. What do we have? 1, 2. Everybody remember your number you get assigned. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the way we can do this on our calculator, let me see if I remember where this is. So I think I do stat, nope. Math, and then probably PRB. Yeah, there it is. Random int. And then we'll go 1 to 13. 13 was selected. That's you, Katie. If we do it again, 12 was selected. That would have been you, Luke. It's weird that these are 2 consecutive numbers. 2 was selected. That would have been you, Isaac. Everybody's okay? Okay. So again, easy to do that with a calculator, right? Oh, boogers. Did it again. I always find a way to whenever I jump out of here and come back in, find a way to not do what I wanted to. All right. This is where we left off. Okay. So another random sampling is something called a stratified random sample. So the basic idea here, again, is straightforward. We're going to take a simple random sample from the population and then use that sample result to gain information about the population. Oh, I see. Okay. I don't know why we have this again. So to do a stratified random sample, you start by classifying the population into groups of similar individuals called strata. So if we're talking about our class, what would be a good way of separating the individuals in our class? Like an easy, obvious way of doing that? Might be gender. Well, let's say biological sex, so as we don't alienate any individuals. That's okay. Gender is a social construct, right? But yes, it's a perfectly reasonable way that we might separate our strata based on biological sex. You could also do something like, what else could you do? Eye color, age, great. These are all great things that you could stratify by. You could do, like household income. You could do, you get the idea, right? We can stratify this in lots of different ways. Again, depending on what you think might be important as far as the inferences you're trying to make, right? Like if you're looking at the effect of, household income on education level, then stratifying by those two variables is probably a good idea, right? Once you've separated your strata, you're going to do a simple random sampling inside of each strata and then combine these to form the sample, right? What's the possible downside? Well, it's harder, right? It's harder to do this because you need a lot of information about your population to form your strata, right? You assume that I can just look at my whole population as a whole, but think about this if you're trying to do this for every American, right? Getting enough information to figure out how do I separate every American into these strata? This becomes it can be potentially quite difficult, right? Now, if you have a census, a 10-year census, that becomes a little easier to form your strata, right? You have some basic information about every American then. Or if you have tax data, if you're the government and you have everyone's IRS data, again, a little bit easier to do that. But if you're a researcher that may not have access to those things, it's hard, right? It's harder to separate and form your strata. Does that make sense? One of the really lovely things about the stratified random sample is you're much more likely to get a representative sample, at least in the way that you're looking for. So again, if we're separating by hair color and say we want to have we're sampling from a population of 100 people and we know 25% of them are blondes, I can make sure that, the sample that I take from those blonde people makes up 25% of my overall sample. So I can make sure that those representation of that single variable is correct relative to the overall population. What you potentially lose out, though, is your sample will likely not be representative versus some other strata, right? So say we do that, but we end up okay, hair color, the distribution of hair color in my sample matches the distribution of hair color in the population. Great. And I look at the gender and it's like, oh, my sample is 90% women and 10% men, right? So it's not representative at all of the population in that regard. But your strata, you nailed, the one thing that you're trying to make sure it was representative of, but you're not representative overall. Okay, so that could still happen, right? Everybody's okay there? Okay. Next thing we're going to talk about is systematic sampling. To get a systematic sample, again, you want to start by determining how many people you're sampling, or how many individuals we're sampling from. That's N, that's the size, cap N, that's the size of your overall population. And how large you want your sample to be, that's little n. So cap N is the population, big N, population is bigger than the sample. Little n, sample size. Sample is littler than the population. Little n goes with the little sample. Big N goes with the big population. We'll determine K by using the formula cap N divided by little n. If K is not a whole number, we're going to round accordingly. And then to find your sample, we're going to pick every kth individual in our population. So let's say that, again, we're sampling inside of the class. Yes. Say our sample size, we want to be 5. Let's say we're on to pick 5 people from our class. If I do 13 divided by 5, I get, like 2.6? So I'll round that up to 3 or round down to 2, depending on what I want to do. So then I would just pick every third person or every other person, depending on which way I round it. So like Diego, 2, 3, Zach, 2, 3, Lucas, 2, 3, Alexis, like that. Everybody's okay there? So here, not quite random, right? Because, again, you guys have chosen to sit together, so presumably the people near you are people that, you might have something in common with. So we might overrepresent a sample in that kind of way. All right. So again, the stratified random sample and the simple random sample are both random, and that can be really hard in practice, right? So if we're talking about the population of the United States, and I'm going to randomly select 100,000 people, I'm going to have people in Alaska, in Hawaii, California, and Iowa, and Kentucky, all over the geographic place, which makes collecting that data potentially really difficult, right? Or potentially really expensive. If I'm trying to go and ask you to fill out a questionnaire, and we're talking about, my sample coming from all over the country, that's tough, right? In practice, most researchers don't have the kind of budget or time to do that. What they're instead probably going to try to do is get a random representative sample just using the individuals that are near one another. So there's kind of 2 ways to do that. So you might start by getting what's called a cluster sample. So that's classifying the population into groups of individuals that are located near each other. Ideally, you're talking about people that live in, a city. Might make a city or a suburb or a town might be a cluster, or even a specific neighborhood or a voting district. These things could become natural clusters. and then choose a simple random sample of those clusters. And then all the individuals chosen from that cluster or clusters are the sample, right? So it's like, okay, we're sampling America. I'm going to pick, I'm just going to sample these neighborhoods in like these 4 cities or something. Or this, this town, this city, and this, unincorporated rural area. So the big question here, and really the core question of all of statistics, is how can we choose a sample that we can trust to represent the population, right? So again, there's lots of ways that you might try to do this, and none of them necessarily are going to be wrong or bad or guaranteed to give you bad, an unrepresentative sample. But they, some of them are more likely to be unrepresentative than others, right? The most common type of sampling really is convenience sampling, where you're going to sample from the population that are easy to reach. Even think about the census, which is supposed to be everyone living in America, is to some extent a convenience sample, because the people that are living off the grid or maybe have illegal status or don't have a, have a undeclared job, right, are making money under the table. These people are very hard to reach and to find. Or people that are homeless or transient or migrant. These are people that are hard to find and sample. People that, have an address and have a job are much easier to sample from in a census than these other individuals, right? Again, though, the problem with a convenient sample is oftentimes you'll get an unrepresentative sample because, of bias, right? The people that are hard to get to are often people that are, or the people that are easiest to get to, maybe we should say it that way, are oftentimes the people most like yourself, most like the researcher. They're going to live in the same area you live in. They're going to travel the same circles you travel in. They're going to be easy to get data from. If we're sampling, even if we're sampling all cars, you walk through our parking lot and just sample cars, well, that's not representative, right? The average income of a Notre Dame prep family is probably much higher than the median income for the state. Cars are a pretty expensive item. Stands to reason, the cars here will be not representative of the whole population. So the design of a statistical study shows bias if it would consistently underestimate or consistently overestimate the value you want to know. So again, if we're looking at something about the average American and we don't include any data about homeless or people with illegal status or off the grid individuals, you're not getting the entire picture, right? Another type of sample or sampling would be like voluntary response sampling. And this is also very common, especially in like political polling. How are political polls most often taken? You get called on the phone, you have to answer, and then you have to be willing to talk to the person, the pollster doing the polling, right? This is an example of a voluntary response sample. You have to choose to answer the phone and then choose to talk to this person. Lots of people are going to not answer, are going to hang up, not return the mail, not read the mail. So you're only getting people to respond that kind of care about what you're asking about, right? Now, again, it's random because you've randomly made these phone calls and you've randomly sent out these letters or whatever, but the people responding to them are not random, right? And just taking the data from the people that respond to you, you've now kind of like introduced some bias into this perfectly valid random sample that maybe you started with. Does that make sense? For example, in political polling, when they're making phone calls, often young people are dramatically misrepresented. Why? Don't have a landline. Most young people do not have a landline. That's how most of the phone random dialing is happening. It's not using cell phone numbers. It's using landline telephone numbers. Again, voluntary response sample consists of people who choose themselves by responding to a general invitation. Voluntary response samples show bias because people with strong opinions are most likely to be the responders. Another type of bad sampling is the quota sample. This is a non-random sampling technique similar to the stratified random sample. So a quota sample is used by first stratifying your population. Then you gather data from each stratum in a non-random manner, so like a voluntary response or a convenient sample, something like that, until you get the required number of responses for that strata. Unlike a stratified random sample, this technique does not select individuals randomly. Rather, responses are gathered until the predetermined number of responses is reached. So it's like, okay, like my strata maybe are just voting districts, and I'm just going to go knock on doors in this one district until I get 10 responses, and then I'm going to stop, just go 10 houses in a row potentially, and be done. Move to the next district, do the same thing, just 10 houses, or keep knocking on doors till I get 10 responses, potentially 10 houses right in a row. All right. So the process of drawing conclusions about a population on the basis of a sample is called inference. This is the goal, right? This is what we want at the end, is an inference, some conclusion we can say about the population to help us, make a decision. Relying on random sampling is really the gold standard in statistics. The reason is you avoid bias in selecting samples from the list of available individuals. So it removes your sampling selection bias as a researcher. 2, the laws of probability allow trustworthy inference about the population. If we choose random samples, results come with a margin of error that sets bounds on the size of the likely error. Oftentimes, again, if you watch any, like at election time, they'll show like, such and such is, leading the vote, 56 to 43 plus, with a margin of error of 7. So that person at 57% could really be at 64, or could all the way be down at 50, right? That's very common, especially at election time. I think we're rounding here to an election here soon. I think they just had primary debates last week or 2. I don't really care that much, but it's like it makes the news. You hear about it. And then even better, the larger your sample, the more likely you are to be representative of your population, right? How would you make sure you're a 100% representative of your population? We take the biggest sample possible, which is the entire population, right? All right. Sample survey. So let's say we gave somebody a survey to fill out or asked them a series of questions. We can create bias in that, not just from the people who we choose to sample, but kind of how we ask our questions. So the sampling techniques. So some causes of some kind of bad sampling. So we can have undercoverage occurs when some members of the population cannot be chosen in a sample. So again, if you're calling people on the phone, who did you undercover? People without phones, right? Or that can't use a phone, right? Maybe they're deaf or they're blind, or like they have some disability that prevents them from using a phone. Maybe they're mute, right? You have non-response. Occurs when individuals chosen for the sample can't be contacted or refuses to participate. Right? We've talked about that. If you're calling people on the phone, they don't answer, or they just hang up on you once you start your spiel. A systematic pattern of incorrect responses in a sample survey leads to response bias. The wording of questions is the most important influence on answers given to a survey. So when we say wording, what do you mean? What do I mean by that?
You don't want to leave them to an answer.
Yeah. Like if I ask you, how much do you hate school on a scale of 1 to 10, I've already kind of planted in your head what I want you to answer, which is I want you to kind of respond that you hate school, because I've already the question presupposes that that's what everybody thinks, right? Instead of saying, rank your opinion of school on 1 to 10, 1 being great, 2 being bad, We're there, we've, given you less of a thumb on the scale of like what I want to say. Everybody's okay? All right. All right. So that's 7-1. What do we have here? 20 minutes or something? Let's not do 7-2 today. I've had that listed, but we're not going to do that right now. Instead, let's go and look at some of these in-class examples here. So I have these just posted inside of the OneNote. We're going to kind of do them just as a group right now to get a feel about this vocab and what we talked about today. So the table below gives information about 10 random U.S. residents from a recent census. Part A asks, what is the population of this data set? Someone want to be brave?
The number of people, the number of residents in the U.S.
So the population would be all U.S. residents in the census. Yeah. Good. Part B asks what variables are being measured, and then are they qualitative or quantitative? Somebody else who wants to give us a answer to that? The variables being measured.
All of them?
Oh, so when you say all of them, what do you mean?
There's multiple variables.
Yes, good. What are they?
State, family members, age, gender, marital status, total income, and travel time to work.
Perfect. Great. Of those variables, notice that just the top of the table was our variables. Which ones are qualitative? Somebody new. State, good. Gender, good. Marital status, excellent. Anything else? No, correct. The other ones are all quantitative. Everybody happy? Okay. 1C says describe in a sentence the individual in the first row. So the first row right here. How would we describe this individual person? Somebody new. We have lots of questions here. We'll all get a chance. I would just include what we know about them, right? So this person's a 61-year-old female. They live in Kentucky. They have 2 family members. They're married. They have a total income of $21,000, and their travel time to work is 20 minutes. Right? Something like that. I just told you what I knew about them. Everybody's happy there? That's not too hard, right? Okay. Part D, based on the given data, what inferences could you make about the general U.S. population in regard to their gender and marital status? So do gender first.
40% population is male.
And then 60% female. Great. What would we say about marital status? Somebody new. Marital status, what would we say? What percent has been married or is married? There's only 10 people. 70%, great. How many are single and never married? 20%. And how many are separated? 10%. Everybody's okay about that. All right. Are these good inferences to make about the population? Why or why not? Are they supported by the data?
Yeah.
Yes, right? What we just said was straight from our sample data. In that regard, there's nothing wrong with the inference, right? Well supported by data. However, what else would you say?
not a big enough sample.
Okay. I would tend to agree with that. Is there a way that so 60% female is pretty specific, right? Is there an inference we could make that might make that more likely to hold up? If we just said there's more females than males, right? There, the sampling is not quite so problematic. And as far as gender goes, this may be fairly representative. I don't know what the population of the United States is by gender, but I think there's more women than men. Okay. All right. Next. Example 2. In May 2010, the Los Angeles City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The Los Angeles Times conducted an online poll that asked whether the city council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. What type of sample did the Times use for this poll?
Voluntary.
This is a voluntary response, right? Because they called up people. The person need to answer the phone and then also to respond to the question, right? Everybody's clear on that? Okay. Explain how this sampling method could lead to bias in the poll result. Somebody besides Diego, who's been doing a wonderful job, but I'd like to hear some other voices too. Explain how this sampling method could lead to bias in the poll results. Okay, what is the specific issue that we're talking about also? Immigration. Do people tend to have strong opinions? Does it tend to be strong in just one direction? Yeah, so who are the most likely people to respond? People that are anti-immigration, right? That tends to be, like, that's an issue where there's very strong opinions, specifically kind of on one side. People that are pro-immigration are kind of lightly pro. People that are anti-immigration tend to be heavily anti. You guys buy that? So it's something that's really a polarized issue. So you're most likely to get responses only from those that have strong opinions, since it's a voluntary response. All right, example 3. A school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books. We've arranged those books by type, fiction, biography, histories, and so on 400 shelves, each of which holds 50 books. You want to select a random sample of 500 books. Explain how to select a random sample of 500 books. Who wants to give a shot at this? We want a random sample of 500 books. How would you do it?
Select 100 shelves. But give each of them a number.
Give each shelf a number? I would not do that, because what kind of books are going to be on the same shelf? The same kind of book, right? And like is a history book tend to be a lot longer than like a fiction book? Probably a lot of time, right? You have some pretty thick, meaty history books there. So I don't know if I would do it that way. Megan. Well, that's assuming that you have equal number of each kind of book, right? I would just label the books 1 to 20,000, then draw 500 random samples or 500 random digits, right? Like that's the textbook random sampling is you just assign everything a number and you pick X number of randomly. Done. You don't have to get fancy about it. You don't have to do any stratifying or anything else. Now, part B says explain how to select a stratified random sample of 500 books. Justify your choice of strata. We'll start there. Okay. Explain how to select a stratified random sample. Well, let's start first. What would your strata be?
Genre.
Okay, genre of book. That seems perfectly reasonable to me. Okay. And how would you then select your 500 books? So we are going to select them from the genres, history, biography, fiction, etc.
You could find out how many genres there are and then divide the 500 by.
Okay. I would also try to like weight my selection. So if like histories are 10% of the books, I'd want 10% of my sampling to come from history books. Right? So I can have, again, the population can be more representative, or my sample can be more representative of the population. But yeah, that's exactly like what you're doing. You're just going to, okay, I'm going to, like there's 1,000 or 5% of my population, like say 1,000 of the books, that's 5%. Our history, of those 1,000, I'm going to select 5% of 500. So like, what, 25? Yeah, so I would do something like that. Why might a librarian choose to use a stratified random sample instead of a simple random sample? We've kind of talked about it already. Different types of books tend to be shorter or longer, right? So if you're looking at the average number of pages, you want to make sure that, when you do your sample, that you have like the representative amount of like histories and biographies and etc. Are there any disadvantage to using this method over a simple random sample? Yeah, it's certainly you need to know how many of each genre you have, which that's a lot harder. What else might happen? Like the numbers could get yucky, right? What if like 13.6% of your population or of your books are fiction, and you try to convert that into a decimal, and it's like, okay, we need 38.4 books. It's like, how do I round this now, right? Because you're talking about a discrete thing with a potential continuous number attached to it. C, it says, explain how to select a systematic sample of 500 books. Megan, how would I do that?
20,000 divided by 5.
Yeah, and then just pick like every whateverth book, 40th or something. Why might a librarian want to choose a systematic sample instead of using a simple random sample? Why might you, as the librarian, want to use the systematic sample rather than a random sample? Think about how, like, actually doing this. Think about you as the librarian actually doing the systematic.
A lot quicker to just go to
Yeah, it's a lot faster to just walk to every 40th book, pull it from the shelf, write down the number of pages, go to the next one, rather than, okay, I have to assign a number to every book. Then I have to randomly pull the number, so I'm going to be walking back and forth as I go to like one end of the library to the other and searching for the number. If I can just walk down the aisle and go, okay, 1, 2, 3, 40, pull, 1, 2, 3, 40, pull, you know, like that's so much faster. Way easier. What's the disadvantage?
Population.
Representation, right? What if there's only 36, you know, like auto mechanic books? You might not get any of them, right? Okay. We got one more. One more. It says, explain how to select a cluster sample of 500 books. Well, I would say that we said that what did we say? There's 400 shelves with 50 books each. I would just pick 10 shelves. That's going to give me 500 books, right?
Yeah.
Randomly pick pick the 10 shelves, but that'll do it. Why might you choose that as the librarian? A lot easier. What's the problem? Yeah, when you pick a shelf, they're probably, most of the books on there are going to be the same genre. You're going to over-represent some stuff. Great. You guys can do the 7-1 homework at this point. That's on page 216. I'll get that up on My Notre Dame. Test next time. Good luck, guys. You're welcome. How about today? How much math did we do? Like none. This sounded probably more like psych than math.